Hey everyone, my name is Jinger Morgan and I'm a 4th grade math and science teacher with St. Tammany Parish School System. I'm so glad you can join me today. In today's science lesson, we're going to talk about energy. Before we get started, I want you to take a look at this short video clip. Okay, so you just watched a video of a toy car made out of popsicle sticks move on its own. It didn't have an engine attached to it, so how did it do it? Do you remember seeing that black rectangular thing on top of the car? What do you think that was? So if you said solar panels, you're right. Solar panels take in or absorb as much light from the sun as possible. In this case, the solar panels attached to the car were taking in all the sun and it transferred it into kinetic energy or energy in motion, which gave it the power to move. So that got me thinking, if light energy can be transferred to kinetic energy, can it also be transferred to different types of other energy? Let's say heat energy. So we're going to build a solar oven to test that question. We're going to see if light energy can be transferred to heat energy. In order to build our solar oven, you're going to need the following materials. So you're going to need a box of some type. It could be a shoe box, it could be a pizza box. I'm going to use a Cheez-It box. It could be a cereal box. Anything will really work. So you're going to need that. You're also going to need a piece of aluminum foil. You're going to need some dark paper. I have black construction paper. You could use a black cloth or a navy blue or something like that. You're going to need plastic wrap. So I have some plastic wrap here. Scissors and tape. And last but not least, actually not last but not least, we're going to need our items because we're actually going to be making s'mores in our oven. So you're going to need your things to make s'mores. And if you have one, it's great. But if you don't, an outside thermometer gauge. If you don't have one, you can just follow along and watch my temperature on mine. But if you do, that's great. So you're going to need those material. Really important though, you need your parents' permission and also parent supervision while you're building this because you're working with scissors and we want to be extra careful. So please make sure that you have your parents' permission and supervision while you're building this. Okay, so let's get started. Okay, so we have our materials. The first thing that you're going to do is take your box, whatever box you're using, take a pen or marker or pencil and just draw a square on the top of your box. Okay, just draw a square. Then you're going to have a parent take scissors and you're going to cut 3 of the lines because we don't want a hole there, we just want a flap. I've already done mine. So after you cut it, you should have a flap like this. So it's still connected on that one side. All right, so that's your first step. The second thing that we're gonna do is we're gonna take our aluminum foil and we're gonna put it in 2 different spots. I lined the inside of my box with aluminum foil, okay? And then you're gonna take some more and you're gonna place it on the flap itself. So we'll do that now. And you wanna try to keep the aluminum foil as smooth as possible. As we're doing this, I want you to kind of also think why we're using the materials that we're using. So why are we using aluminum foil? Why are we using the black or dark material? Okay, so I have my aluminum foil on my flap like so. All right, the next thing that you want to do is take your dark material. I cut mine a little bit smaller and you're going to place this in the inside of your box. I'm actually going to tape mine down. This is where this s'more is going to be. You're going to place the s'more. So it really doesn't need to be, I mean, depending on the size of your box and depending on how many s'mores you're making, it just needs to kind of fit that. Okay, so I have my piece of black paper in there and my flap. I'm gonna go ahead and close this side of my box All right, so I have my box with my flap of foil. Inside is lined with foil with my black material right there. Okay, so the next thing that we're gonna do is we are going to take our thermometer and we're gonna place it inside, because we're actually gonna be testing the difference in the temperature inside the box versus outside the box. So you want that to stay in there. Again, if you don't have it, just follow along and use mine. And then we put our graham cracker and build our s'more marshmallow. Okay, and so that's gonna sit in there like that. Okay, so I have my thermometer and my s'more. And then the last thing that we're gonna do is take that cling wrap and we're gonna cover the hole that we had. And you wanna tape that down. You want it to be tight, and use your tape to secure it down. All right, so as we're doing this, let's talk about light energy for a second. So light energy behaves in several ways, right? It can be absorbed, light energy, which means it takes in as much light as possible. Think of a sponge taking in all that water and hold it in, right? So light energy can be absorbed. Light energy can be reflected, meaning, right, think of a mirror image, something is reflecting back at you, and it hits that object and bounces back, right? It's being reflected. And light energy can also be refracted, meaning almost looks bent. It's traveling through different materials at different speeds, so it looks like an object is being bent. So keeping that in mind, a second ago I asked you what's the purpose of the aluminum foil, what's the purpose of the black paper. So knowing how light energy behaves, what do you think the purpose of using the aluminum foil is? Is it for light to be reflected, absorbed, refracted? Right, it's shiny, so it's for the light to be reflected off of it. So what do you think the purpose of the dark paper was? It's for the light to be absorbed. Good. All right, so the last thing that we're gonna do is we want to keep our flap open at a 90-degree angle. So just kind of put it at a right angle, right, 90 degrees, and I'm gonna use tape to secure it down at a 90-degree angle. That didn't work. We'll try again. Okay, perfect. All right, so I'm all ready. I have my plastic wrap all taped down. I have my thermometer inside and my s'more in there. So let's go outside and get started. All right, guys, we are outside. We have our solar oven in the direct sunlight. Outside, the temperature currently is 73 degrees, and inside our solar oven, we can see that it is well past 73 degrees. It is already, looks like at 120 degrees inside our solar oven. All right, so we're going to record that temperature, then we're going to wait 15 to 20 minutes, and we're going to check back to see how the temperature has changed and see how our s'more has developed and cooked. All right, guys, it's been 20 minutes since I first put our solar oven outside. If you remember, it was 73 degrees outside, and inside the box was reading right at 120 degrees. It's still 73 outside 20 minutes later, but inside the box, inside our solar oven, it is reading well past 120 degrees outside. Let's think back to our original question. Can light energy be transferred to heat energy? Well, What do you think? Yes, absolutely. Our oven got a lot hotter inside versus outside. That's because of the materials that we used. The aluminum foil reflected all the light energy, the black paper absorbed all that light energy, and that plastic wrap contained or trapped all of the heat inside. Remember, energy can never be destroyed. It can only change forms and turn into different types of energy or transfer into different types of energy. All right, now what you've all been waiting for, it's time to enjoy your s'mores. Thank you guys so much for watching. I hope you enjoyed it. Remember, you can watch daily lessons on STPPS TV or on our website. Everyone stay safe, and I really hope to see everyone soon. Bye.